Assalamualaikum and a very good day. My name is Nur Shafika and I'm going to present my final year project entitled Development of Starch-Based Film Containing Essential Oil for Food Packaging Application. First of all, nowadays we can see that plastic products have widely produced for various applications. Here in the first figures shows that about 48% of the market segments for plastic products are used for packaging application, include food packaging application. Next, as you can see that the second figures, it shows that food wrappers or containers contribute about 7.70% of the marinators, which can be considered as a quite serious issues that need to have attention nowadays. In these modern days, petroleum-based plastic are widely used in the food industry. Despite being widely used, plastic made from petroleum can lead to environmental impact. So, biopolymer can be one of the alternatives to replace this. Biopolymer can come from various resources, and starch is widely used nowadays. Okay, next for the problem statements in this study. Firstly, to counter environmental problems arise from the usage for petroleum-based plastic, starch-based film is another alternative. But starch-based film exhibit poor mechanical properties, so it can be overcome by the addition of glycerol and essential oils. Nonetheless, the type and its concentration of the essential oil will have strong influence on the properties of the film produced. So, the effect of different type and concentration of EO in terms of its optical and mechanical properties of the film as well as the shelf life of the packaged film are essential to investigate. The objectives of this study is firstly to produce and characterize starch-based film incorporated with different types and concentration of EOs. Next is to investigate the shelf life of the strawberries wrapped with the produced film stored at chiller for 9 days in terms of its weight loss, color change, and firmness. In this study, the flow of work begins with the production of the films using solvent casting method, and then the characterization of the produced films in terms of the optical and mechanical properties, and finally the shelf life study of the strawberry wrapped with the produced films and stored at 4 degrees Celsius for 9 days. The shelf life will be determined in terms of its weight loss, color change, and firmness. Next is the result and discussion part. Firstly, the thickness of the film were determined and discussed. The thickness of the films are important as it will affect the mechanical and optical properties of the film. The study found that the addition of essential oil on the starch film increased the thickness due to a difference in the material concentration of the oils. Next is the optical properties of the film in terms of its lightness. The lightness decreased with the increased EO concentration added into the film, which indicate a slight darkening of the films with EO's addition. Okay, next is the redness value. A star values or redness decrease slightly with the addition of EOs. Lower A value of the film indicate that the film exhibit a slight loss of redness. Next is the B value, which indicate the yellowness of the films. The study found that there were an increased trend of the B value with the addition of EOs. For total color difference, which to distinguish the color difference between the starch with EO and the starch without EOs, there were an increasing trend of the total color difference, indicate there was a slight color variation of the films. In terms of the film opacity, the opacity of the starch film increased slightly with the addition of EOs, which indicate a decrease in film transparency. Then, for the mechanical properties part, for the tensile strength of the film, it was found that the tensile strength of starch film decreased with the essential oil addition. The reduction became more prominent at higher EOs concentration due to the plasticizing effect of the oil. Next, the EAB value of the films. It was found that the EAB value increased with the addition of EOs due to the strong intermolecular polymer-polymer interaction were partially replaced by the weaker polymer-oil interactions. Next is the Young modulus parameter. It was found that the addition of EOs in the starch film reduced the young modulus of the films. The film became less stiff and exhibited improvement in flexibility. Next, for the application of the films, the weight loss of the strawberries were recorded. There were gradual decrease in weight loss during storage. Weight loss of strawberry wrapped with the starch EO films was lower than the unwrapped strawberries and strawberries wrapped with the starch film without EOs. For color change in the strawberries during storage, the lightness would decrease during storage, but red strawberries exhibit higher lightness compared to the unwrapped, indicating that the film effectiveness in preventing color deterioration of the strawberries. The A value or redness value generally decreased with the increase in storage period. The lowest reduction of redness was found in strawberries wrapped with the starch EO film compared to unwrapped and wrapped strawberries with starch film without EO due to the several factors. Based on figure here, the strawberry wrapped with the starch VEO film was much better at the end of the storage. All the strawberries experience a loss in firmness at the end of the storage, but it is much higher for unwrapped strawberries compared to wrapped strawberries. The strawberry wrapped with the starch EOS film shows a decreasing trend due to the barrier properties of the film that reduce the respiration rate of the fruits. In conclusion, the addition of essential oil into the starch film improved the properties of the films in terms of flexibility and stiffness, and the films are promising for food packaging application, especially for the extension of the shelf life of the strawberries. The starch films incorporated with the 1% concentration of PEO can be said as the most effective films.